Communicate the idea as this rounds out chapter 1. Look at the pictograph. Is this a good way to show the data about how the students get to school? Circle yes or no and give one reason for your answer. Well, let's have a look. Transportation doesn't really explain what the transportation's for, so there's a little bit missing there. We've got images here for walking, 1, 2, 3, 4, 5, 6, 7.5 images. Biking has 1, 2, 3, 4. Driving has 1, 2, 3.5. And each of those symbols represents 10 students. Yeah, it's a good way to do it. The data can easily be counted and the symbols are appropriate. We do have some half images, but those are clearly half. So the images can be easily read and counted. Is it misleading? Somewhat. I would say yes. The proportions of spacings and sizes, they're all about the same size, but the spacing is a little off. If you look for 3.5, there's 3.5 cars, which is the smallest quantity. 3.5 bicycles is about the same place, but 3.5 people is way back here, as opposed to up here. So the spacing isn't quite right. The spacing is not equal in each category. They're approximately the same size symbols at least, although the cars and the bikes are more horizontal. The stick figure is more vertical, but they are about the same size. It's just a spacing issue. Would changing the number of students each symbol represents make the graph better? Yes or no? Since we've got some halves, you could change it to 5 per student or per image, and then you would have only whole numbers. So yes. Using 5 instead of 10 would result in only whole symbols. Ten is an easy number to count by, so there may be some benefit to go with that as well. What other kinds of graphs could you use to show the data? You might use a bar graph. If you turn the pictograph on its side, it's almost a bar graph already. So a bar graph is an easy transition. Line graph would not be appropriate. Double bar graph wouldn't be appropriate. Circle graph could be done, but then you're looking at the information in a different way. Number 2, Danny made this graph to record his running times over 6 weeks. What is happening to Danny's run times from week 1 to week 6? Well, they are decreasing. Which means they're getting smaller. starting at 90 and then going all the way down to 76. It looks like it's a big drop, but it's not a huge drop. How does the scale affect the way this graph shows its running times? It's jumping from 0 to 76, so there's a break, but then it's going up by 2s. The break makes the final times seem much smaller than they really are. How would you improve the graph? Remove the break. And count all the way up from 0. Then all of a sudden 76 is going to have a much larger bar next under it. Because the way this is drawn, 1, 2, 3, 4, 5, 6, 7. Week 1 seems like it's 8 times bigger than week 6, which really, it's just an extra 14 minutes. Number 3, your friend missed the classes on how to critique graphs. Explain how to judge a graph and why it is important to do so. So, look for inconsistencies. In data representation. So, wide bars, different symbol sizes or spacing or breaks. Those are the main ones. And explain why it's important to do so. Initial reactions to a misleading graph can be incorrect. From a marketing perspective, misrepresenting data might be to your advantage. But as a math student, graphing data, you want to be accurate and you don't want it to be misleading. And that is now the end of chapter 1.